How are you, my top boss? Welcome to our today's stream. Today we are talking about this important concept in electrical that we can't afford to lose or not to discuss about, which is definitely electrical troubleshooting. Very important aspect when it comes to an electrician's life. That is what we have on our board, and I will definitely be using it to guide us. So with me, I have something that is extremely basic, if I should say. So we have the consumer unit. We also have various circuits that we normally use. Sep, hi to you. Good to see you joining in. So on the consumer unit, we are going to learn a lot. My top boss, definitely. I think that is what we should begin with. And from the consumer unit, what you can see here, maybe you might say that it is too much, John. Why would you have an SPD, surge protective device? Why would you have it in the consumer unit instead of having it in a meter box? And you are right. Assuming it is in a rental property and you have a lot of, customers that have fed from that section, from the meter board, then unless they have a surge protective device that is mostly a three-phase, you have to be safe in your house and have that SPD. The SPD is like connected in that loop of the electricity that is flowing. So there is no input and output. There is just the L and N connection. That is what we have, right? Samuel Saki, good to see you. George Onyango, wow, karibu sana George. Mudo Sesei, hello. And Joseph Mwangi, good to see you, top bosses. Thank you so much for tuning in. And if you are just joining in, smash that like button. And if you are not subscribed to my channel, top boss, subscribe to our channel. Very important when it comes to electrical troubleshooting. I have this. What is the name given to this, my top boss? Today, this session has to be very interactive. What is the name given to this important instrument? If we don't know these instruments, then we are going to have issues when it comes to electrical troubleshooting. What is the name given to it, my top boss? Very important instrument. Any answer from you, my top boss? Who knows the answer? Let us make this session as interactive as possible, my top boss. Yeah? I have my top boss, Hendrix Cassandra, says, hi, top boss. All the way from Zambia, says RK Zambia. Thank you so much. Raymond says, hi, I am watching from South Africa, Limpopo to be specific. Welcome, Raymond. Thank you so much. Beloved says, clamp multimeter. Clamp multimeter. That is from our top boss, Beloved. Thank you so much for that. And I have another one that we will be talking a lot more about it today. This one, my top boss. A lot of features for electricians. Most of the people think it is supposed to be used by electronics engineers or the engineers in the What do we refer to that as? Control systems. But an electrician uses it a lot. Hmm? A serious electrician will use it a lot. When installing solar panels, you find its application on this section, especially if you are taking the readings from the panels direct. So what is the name given to this important instrument? Top bus. An electrician will use it in his course of, you know, works. Beloved is from Nigeria. Karibu sana. Welcome. In Kenya, Swahili, we say welcome, we say karibu. Evans Kiplagat says, hi, I am electrician Evans from Kapsowar, Elgeyo Marakwet. You are so much welcome, and I'm so much honored to have you, Evans Kiplagat. Modose says, me, I'm an electrician. I'm from Gambia, West Africa. Good to have you, my top boss, Modo. Jacob Obwocha says, hi, top boss, great lessons. I'm from myself, I'm a beginner. Incredible. You are so much welcome, Jacob. This is the best channel for you because you know what? My main focus is beginner electricians and student electrical engineers. Mchimchi says multimeter, correct. Thank you so much for that. Chuku Victor says, Victor from Nigeria. Welcome, my brother. Jacob says, this is a digital multimeter, correct. Incredible. This is a digital multimeter. For those who are joining in, thank you so much for joining in. And today we are celebrating 45,000 top bosses on YouTube. Mm, mm, Thank you. Thank you so much for making it to this number. I never in my wildest thoughts imagine would get to 45,000. You top bosses are on a different level. Now, most of us are used to a scenario whereby you may find one MCB has already tripped. How do you deal with that situation? First of all, let us activate our circuit here. You know that one is it's not an easy task, but we're going to do it anyway. We have to activate our circuit. So assuming that this circuit assuming that this circuit is supposed to give us readings, what are we expecting? Especially now from the consumer unit, a customer has called you and has told you that, you know what, there's a problem with my sockets, there's a problem with my instant shower head is not powering on. What do you do? The best thing is for you to get to the customer and understand what could be the problem. You get there, you now start carrying out the troubleshooting exercise. You start helping the customer find find a solution to their problem. That is basically the work of an electrician, isn't it? You solve a customer's problem. That is how you get rewarded. Customer has complained that they are having a challenge. So your main focus is to provide a solution to them. I'm trying to activate my circuit. Boop. There we go. The circuit is now live. Why am I saying it is live? From the look of things at the digital multimeter there, it is on all the way here. So my top boss, assuming that going with what we have at the consumer unit, the customer has said that there is a problem. Now all you need to do is to turn on your digital multimeter. We expect the readings to be 240, because that is AC. All right. So all you need to do is to ensure that you place your digital multimeter at a safer place. Really, will we be able to see that? So we expect our readings, and especially for that circuit, our question will be, maybe the customer has said that there is a socket for the washing machine, it is not working. You have gone to the, to the consumer unit, because the consumer unit, why go to the consumer unit? That is simply because the consumer unit is the heart of any electrical installation. And for any problem, you expect to, have a consumer unit fault that is a tripping, MCB. Raymond says, hi, top boss. I like the way you call circuit. Nice. Oh, it's supposed to be circuit or circuit or what? What is the difference between this and clamp meter? Very important question right there. Cassandra is asking, top boss, do we have the difference between clamp meter and multimeter? Chuku Victor says, what is the difference between this and the clamp meter? Is it important for me to elaborate that? Of course, yes. If you have brought it to my attention, I think I should. So now there are several things here that we need to check for this digital multimeter as well as the clamp meter. So both of them have the probe functionality. That is a unique, a feature about them. They have the probes. So like the clamp meter also has the probes. And even for the digital multimeter, it has its own probes connected here. Now, for the digital multimeter, it is easy for you to record the capacitance of a capacitor. The provision is here, CX. All right. For you to record readings for current, the current that is flowing in a circuit, you will have to disconnect that circuit. For instance, if it is this circuit, we want to determine, you see, I have a light here. There's a bulb that is here on this circuit. So if I switch it on at that MCB, of which I can as well switch it at this switch here. You see that? So if we want to determine the current that that bulb is, consuming using the digital multimeter, this one, we'll definitely have to discontinue the circuit or break the circuit and then insert the probes in series so that we can determine the current that the bulb is consuming. Now, if I wanted to determine the current that is flowing through the bulb without interrupting the circuit, I will definitely use a clamp meter. How? I will simply disconnect, or not disconnect, I will simply take the face, or this one, the line, not the face, the line, and then I will turn my clamp meter on, and then based on what I expect it to be below than 60 amperes, definitely the consumption of the bulb. So I take it all the way to 60 because my clamp meter can record all the way up to 600. I will take it to 60 amperes, but again, the reading is in DC. I need to select to AC. See that? To AC. Once I do that, I will then come and hook it here. So I'll hook it, and the current is very, very small. In fact, it is not detected by my, look at that, it's still 00. Yes, it's the clamp meter. Afro Junubi says, much love from Sudan, sir. Thank you so much. Krishna is asking, is the device clamp meter? Yes. Techno Mohan says, this is mega. No, it's just a clamp meter. So if I turn my bulb on, I'm recording nothing. Who can guess? Who can say what is the issue here? Current flowing there. This is resistance check. The Techno Mohan. No, current. So it is at AC. It is at AC, and then I have connected it at the. So that is. So if I select that, we have AC, current. Therefore, if I place it on the line, what if I place it on the neutral? Does that make sense? So that maybe there is a mistake that we made in the wiring. Nothing. Right. Lightning doesn't consume 60 amperes. Yes, but at least it should have given us 0 point something. So I guess it is too small for that. Now I have a load here. Let us connect an iron box on this socket here. If we connect an iron box, we have a 32 ampere here, which is going all the way to this socket. And then we can use the digital, the clamp meter. So this is the iron box, right? Much is it rated at? It is 1100. So if I plug it in the iron box, iron box is on, you can see. First of all, let me have the reading. So I will simply lift that cable that goes to that meter. Able to see the recordings. So if I switch it on, my iron box is on. What do we have? Hey, really? 0.1, iron box is on 0.1. If this light disappears, it means that the thermostat has been deactivated. We expect zeros here. So let us see. There we go. Zeros, meaning the iron box is off. So if you're finding value already, my top boss, smash that like button. And if you have not subscribed, subscribe to my channel. These are the type of videos that you expect. Clamp meter. Is the clamp meter enough? So I will wait for the iron box. It is at max, so even if I try to turn that knob, it won't help. So the iron box is on. Boop. It has already turned off, and there were some readings that were recorded right there. As you can see, 0.1. Yes. So it explains why for the bulb there was no reading, because the bulb consumes very little current, right? Isaiah Abdu said hi, thank you so much. Fabiano Lengewa says, then read the input voltage of the load to compare the readings. Voltage is still constant because the connections here are parallel. I subscribe to your channel. That is Krishna Pratap Sai. Thank you so much for subscribing to my channel. That means you believe in me. Can you describe how to connect a generator MCB? I will do that in future videos. Fabiano, you are talking about the connecting that. So I've already demonstrated that actually the lighting was consuming very low current. That is why it is like that. Abdul Majid says, post this. Yes, this live stream will be posted as a recorded version. All right. So that being said, we want to conduct. Our customer has said that probably there's an issue, or even if we turn this MCB which is disconnected on, then we turn that off. You notice what? The bulb is off. The bulb is off. The customer has said that on the porch or in his corridor, or probably the kitchen light is not working. That is the kitchen light. It is not working. You have been called as an electrician to go and check what could be the issue. Where do you start? Do you start by replacing the bulb? Do you start by going to the switches? The customer is clueless. As an electrical technician, you understand that probably there are a lot of issues in that home. Now, you definitely may go to the consumer unit, but one thing can stop you. If that lighting is serving several areas, I mean that MCB is serving several areas. So let us take this scenario. The kitchen light is off, the dining room light is off, and the corridor lightings are off. All right? So that does not mean that all of those lights blew up or faced the same problem, and yet the bedroom lights are on. So that is when and only when you go to the consumer unit and you discover that there is a problem here. The MCB has tripped. So before lifting that MCB, what should you do? Now that is when now you take your digital multimeter. You take your digital multimeter and Before turning it on, you take what we refer to as continuity test. At that time, you must ensure that all the lights, the switches are off. Why? Switches are off, the MCB is off, but you take a continuity test. Why? So that you can ascertain, is there a short circuit between the output of the circuit that is serving those areas. Right? We are talking about the area in the dining, which is off, the kitchen lights are off, as well as the corridor lights or the balcony lights. So you go to the continuity test to ascertain, was there a short circuit? A short circuit is detected this way. It is actually a measure of resistance. So if you place the probes together, you expect that beeping sound. Most likely you will expect zeros here or a very smaller number, meaning that there's a problem. It is like doing this, my top boss. It is like taking a wire, you know. Is it a wire or is it a cable? It's like taking a wire such as this one. So that is how to detect an issue to do with again, in this lesson we are going to learn that the correct tools for specific work are what and what. When it comes to electrical installation or electrical maintenance, ensure that you have the correct tools. What is the name given to this tool that I am having here, my top boss? Kabanda Jamil says, so real and educative, sir. Thank you. Fabiano says, yeah, sure. First, check the JB. Maybe there is loose connection. Are you real? Are you for real? JB, is that the first procedure? Krishna says, sir, please give here to how to low electricity bill in a month. First of all, check on loose connections. The first thing is if you have loose connections in your circuits, that will definitely lead to a spike in electricity bill. Number two, the wrong wire. All the cables that you have used in your wiring are the wrong ones, meaning that they will overheat due to that resistance. That overheating, that resistance will give a bad signal on the energy meter. Evans Kiplagat says, when it comes to field work, your lessons have helped me a lot. Be blessed. Thank you so much, Evans. I came for that. Evans Kiplagat goes on and answers the question that I asked. What is the name given to this tool? He got it right, said wire stripper. Cable stripper, that is Fabiana Lengewa. Abdul Majid says, you are good, sir. Thank you. Now, you as an electrical technician must be responsible of taking care of your tools. You see, I was negligent and now my tool is rusty. So I went to the stores and got this oil here. I'm going to use it to apply it on my, cut a big one. Apply it on my tools here. Used to have such oil in back in the day when I was a kid. My father would tell me, go and bring that oil, we apply on either the pliers. It really supported my work. So once you're done, just cover it like this. Hey, what have I done actually? Yeah. So to protect my tool, this tool of trade, you will not use it just once. You're going to use it on several days. So you must ensure that your tools are well maintained, my top boss. So servicing them. I'm using this live stream to service my tools as well. Right, so this one is a stripper. So what I was saying, this is a cable. This cable is continuing. The only way we can prove that it is continuing from here all the way around to here is using a digital multimeter and test for its continuity, isn't it? So taking our probe, we record from one end to the other end. So we place on one end like that. On one end here, and the other end we place the other probe. Okay, so if it gives a beeping sound as well as zeros, we understand that the resistance is very very low, sorry. All right, so the same concept applies. It means that that is a short circuit, right? This is a short circuit. So there are instances in a circuit where you don't expect a short circuit. First of all, between the neutral and the earth connection, you don't expect a short circuit there. Between the neutral and the face or the line, we don't expect a short circuit right there. If there is a short circuit, there is a problem. Sir, can you use one circuit breaker for both an AC and lightning circuit? No. Why? Because if at all there is a problem in the AC, if there is a problem in the, if for instance you want to use a 20 ampere breaker because you want to accommodate the AC instead of using a 6 or a 5 ampere breaker, which is meant for lighting. In case there is a problem with the AC, with the light, it will not trip the breaker because that breaker is too big for that problem. So the problem may escalate into burning the house. If at all there is a bulb that has a short circuit internally, it will not trip that breaker. And so you are supposed to separate. But that is a good question, Majid. Have I answered it correctly? Lengewa is asking about my daily routine. What is the time that I go live? Most cases I go in the evenings. During the day, I'm in the field working. For instance, today I was somewhere replacing an instant shower head. Fabiano says, no, lightning circuit is a final circuit itself and amount of current consumed are different from lighting and socketing. Absolutely. So when it comes to the AC, it has to be a completely different circuit. Okay, the AC. And it is good that you have asked that question. It is normally good to have different circuits. So if we find that this MCB has tripped and the lighting in the dining room is not available, okay, we have to ask ourselves before we turn it on. There could be so many reasons why this MCB is off. Ooh, power is off, my guy. Electricity has turned off. So I will have to use my backup. Just a minute. Let me get my backup. Bear with me, top bosses. Let me get my backup. So I have a backup that I'm using here. This one. How do you like it? This is a lithium from the lithium company. I'm using it. I was supplied with the company, So this is what I'm going to connect for our circuit as well as our lights. It's power back. There we go. I hope it doesn't interfere with the Wi-Fi. Fabiano is asking evening from which time? Mostly from around 9. Sir, link me to your company. I know you might have a company. I'm good, but I lack field experience. Kindly. Yeah, so what you need to do is J4K is asking, it's that C4. I don't know what you're talking about. Yeah, so I think power is even back. So we'll not have the issue to do with Wi-Fi problem. So what I'm going to do is to proceed with our today's lesson. No. Able to see my digital multimeter there? There's something interesting that is happening here that I would like to bring to your attention. The wait is too long here. So this AVS filters the power that is coming in before it can allow it to my inverter here. So the wait is too long. What could be the reason for that wait? It has taken too long than normal or than usual. Once this AVS gives a go ahead, it has done that. We see on our inverter also there is another delay. So there is presence of power, but it has not been allowed to flow to the loads. There is a delay, and finally, due to that click, power has been allowed to flow in. And so power coming in has to really be sieved. Oh, he's asking the size of the breaker. Fabiano, thank you so much for being very proactive in this stream. I appreciate the size of the breaker. What was the question again? Let me just try to find it. He has deleted the message. I mean the comment, and so I can't really get back to that. But if he was talking about the, you see the C6, C16, C20, C20, C32. So that is the current that can be allowed. There was a question that I was asked about RCCB. I don't know whether I will be able to get it. And who asked that question? Let me just try to find that. There's a question about RCCB. Yeah, I found it. From Evans Kiplag at our top boss says, what is the work of RCCB? Normally, mostly electricians don't use it other than the MCB. I agree. I agree. So let me preserve my backup. And switch back to the main power or the national grid, so that if there will be an outage next time, I will not have an issue. The RCCB, as Kiplagat has rightly put it, is not common with most electricians. The purpose of the RCCB, as you can see, power is coming from the power supply connection from this main switch or the isolator, or the MCB has a lot of names. Let me just give you a closer look. So the RCCB is connected in this manner. The output from the MCB is fed into the input of the RCCB and to the circuits, the various circuits that we have. So what you are seeing here, Andeli is the main switch. All right. So you have the main switch. Fabiano says, thank you, sir, but consider my objective about connecting me to your company. I really need a field experience humbly. All right. I don't know where you are, but you can start by volunteering in your nearest construction site. I've come prepared, armed with the gloves. Remember, this circuit is on. So from this point here, we have, first of all, electricity flowing in through this point, right? So at this point, we have L and N, and it is tapped to the top part of the MCCB, sorry, miniature circuit current breaker. And then the output here is fed to the RCCB. What is the purpose of an SPD, surge protective device? As the name goes, it protects the customer, the circuit against the surge, which comes from outside. If it is internal, it is only limited up to the meter. So assuming that we have a surge here, how can a surge come about? Loose connections on the neutral. Suspect number one, a loose connection on the neutral. If a customer ever calls you and tells you that they had an issue whereby there was burning of bulbs, TVs, and the lights, and the neighbors are not affected, that is an internal fault, a localized issue. Mostly, it is a loose neutral. If the neutral is loose, it will lead to a surge. And that is normally what we locally refer to as a return, a loose neutral, a loose connection on the neutral. Right? So if there's loose connection on the neutral, that is why I normally say that neutral is king. The neutral should never be disconnected under any circumstances unless you are switching both the phase and the neutral. But you cannot disconnect the neutral only. Even at the transformer section, the neutral is very, very highly respected. You find that the fuses or the fuse carriers are only connected on the lines. So from this bottom section here, we have at this point we have the output. The output, which is the neutral, feeds these neutral bars, right? These neutral bars from the RCCB, and then the live or the line feeds the MCBs on the top, and then the MCBs feed the respective circuits at the bottom. What is the purpose of the RCCB? The main purpose of the RCCB is to determine any inconsistency or any drop in current on the circuit or in the circuit. So at this point here, we have the phase that is coming in. If let's say the current flowing through is 5 amperes to this live, it has to go through all the circuits and then come back through the neutral. So it will come back through the neutral and flow that way back to the transformer. So this RCCB continuously monitors that flow of current. If it is 5 amperes, it ensures that it is 5 amperes throughout. If at all what comes back is 4.9, it simply trips. What is the reason for tripping? Assuming that someone is receiving an electric shock on the other end, means that there is some current that is leaking from that circuit. Remember, a circuit is the flow of electrons, which we refer to as current, flowing inside a current carrying conductor from point A and then back. Can't say from point A to point B. It flows from one, it's like a circle, eh? So it has to flow in a circle. So if it is 5 amperes, that 5 amperes must flow through that loop without losing it. So if it is zero, like here, this RCCB is rated 40 amperes, and it can easily trip at 0.03 amperes or 30 milliamperes, and that is in a period of 0.1 seconds. Okay, so in case it senses that there is a current that is 30 milliamperes, it will trip within 0.1 seconds. So it monitors the flow of current in that loop. What is coming out, what is coming back. If there is a minimum, a less of 30 milliamperes, it will definitely trip. How do you know to open or close circuit breaker, or are they of different types? Majid, I'm not understanding your question. So assuming the customer has called you and this MCB here has tripped, there is a problem. It simply means that, for instance, the example we were giving, there is no power in the kitchen, no lightings in the dining area, and also the balcony or probably the corridor. Then it definitely cannot be that the bulbs in those sections blew up. So as an electrician, your first instinct should send you to the consumer unit, and that is where you find yourself here. And once you are here, you discover that there is an MCB that has tripped. And the reason why you will know that that is the MCB for lighting, it is because it is the smallest MCB. Assuming that we have a C16 for lighting as well, or a 5, that is okay, because in other rooms, there is a presence of light in them. Now, this MCB has tripped. Do you go ahead and lift it? No. That will be guesswork. What you need to do, you now consult your digital multimeter. How? You have to know how to use a digital multimeter. The first instinct, if it were me, I would find out why that MCB tripped. Okay. Number one reason could be there is a short circuit in that line. Either one bulb in the corridor or the light in the kitchen has a short circuit, or if it is on the balcony or the dining section, there is a problem there. That is why this MCB tripped, and it cut off the supply of current to those areas that I've mentioned. So what you need to do is to simply take your is to isolate that line. For instance, you can simply disconnect this cable like that, Another issue why this MCB could trip is what? What could cause this MCB to trip? Probably due to wear and tear. Because if it has been supplying those circuits for whatever period that it has been supplying them, let's say it is 6 months, 1 year, and it has tripped, probably it is due to wear and tear. But again, it is uncommon. Once you have isolated this circuit, you can switch the MCB on because it is not connected to any circuit, and then you can test for the continuity of that MCB. So the MCB is continuing. So you place the probes there, and because you are testing for the continuity, if you switch it off, there is no that, you don't have that sound, and your multimeter gives a 1 meaning infinity, right? Put it on, there is that sound. You have zeros meaning a short circuit, right? Fabiano says over voltage can also cause it to trip, lose connection, and wear and tear. You are right about wear and tear. Lose connection, not really. Over voltage, also not really. And over voltage will not be stopped by an MCB because it is an outside thing. The MCB stops what's in its internal, right? Because the voltage that is coming in is pumping power to the circuit. But the appliances or the circuits that are connected are drawing power from the circuits through the MCBs. And the MCBs protect any short circuit on the side of the appliances or the load. But it can never stop what is coming in. If the voltage, the current that is coming in is 10, a 6 MCB will not trip. What matters is on the other side, on the end of the MCB, for instance, the load that is connected. For instance, if you were to connect a heater on the C6 MCB, it will definitely trip if at all that heater draws, like, let's say 25 amperes. That one exceeds 6 amperes rating of this MCB. Makes sense? Now, having done that, we now ensure that we switch off every light of that setup. And then we test for a short circuit between the line and the neutral. There is none. All right? Between the line and what? The earth connection. There is none. And you can start switching on every single light and testing. But again, instead of going through that tedious process, another thing that you can do is to simply remove the bulbs one by one. Assuming that you have the bulbs that are not lighting, remove the bulbs, the lights one by one, the lightings, fixtures. Maybe there is a high chance that there is an internal fault in the lighting fixture, be it the bulb, be it a chandelier, whatever lighting fixture that has been used there could have an internal issue. All right. Another problem is the holders. If, for instance, there is a short circuit in the holders, it could lead to that short circuit. And another culprit could be here. Here, most likely. Why there? Assuming that this house has a ceiling in it, inside there is a ceiling. And assuming that we don't have these WAGO connectors, the connection that has been done there is wires that have been jointed or bundled together or twisted together, and there is insulation tape that has been used, which is not really insulating the cables, that is definitely going to lead to a problem. So if at all you find that at this particular point, at this point we had issues whereby the phase, the line and the neutral were in contact with each other. That is what we refer to as a short circuit. The line and the neutral have to be separated, have to be very independent. So if there's a situation whereby by any chance the line and the neutral were in contact, it will definitely send a signal to the MCB, and that is how the MCB will trip. And this light here will not receive any flow of electricity or current, causing the MCB to trip, as we have seen there. Now, once you have sorted that problem, all you need to do now is to connect everything again, because let me even demonstrate. Assuming that we didn't have, just turn my camera for you, my top boss. Assuming that we didn't have the Wago connectors, see how easy it is to use Wago connectors. Assuming we didn't have the Wago connectors, and these cables here were twisted together, and then they were short-circuiting each other. So I want to come up with that scenario. So this is a makeshift problem. Does that make sense? So the neutral and the line, or the neutral and the phase, have clashed right there on the circuit of our light. So the MCB right there is down, or it has tripped. What we expect is a short circuit between the line and the neutral. So if we connect here and here, there we go. We have the beeping sound. We have zeros on the meter as opposed to very high resistance. So that is the problem that is here. Once we get rid of it, and then as you can see, so we separate that, right? Once we separate that, and then we also test the circuit, outgoing circuit to that light, and place the probe on the outgoing line and the neutral. It is an open or infinity, meaning there is no short circuit. Once we have proved that, we established where the problem was, and probably that joint was not properly done, we now bring in our expertise by simply doing the right thing, which is connecting that properly by use of Wago connectors. So the face and the face will be connected together. Then the other line, insert it in there, connect the Wago connector. And then for our neutral, bring in that, then we clip, and lastly, incoming neutral, connect it in, clip. So everything is separated. See? So the neutral is coming in and exiting. The line is coming in and exiting. Place them right there, like so. Right? So once we have done that, we are quite sure that indeed we don't have an issue to do with the short circuiting, right? I'm looking for a cover. I don't seem to get one quite easily. We'll do that. So that being done, okay. So that being done, we have already established that we have sorted that problem out. Still switch on our digital multimeter there. Before we reconnect back the MCB, we also test for that it's infinity. Line and earth infinity, so we are sure there is no issue. And then we reconnect back. If the problem was with the MCB, you'll find that after doing all the checks, right, and you have ascertained that there's no problem, you reconnect it back, and then after the lights are on, it trips again, you definitely know there is a problem with this. And especially after taking the readings, you can also replace it, because it's just one MCB, you can replace it with another. If it doesn't trip, it's a clear indication that that MCB was the one with the problem. So we reconnect our cables back, and then assuming that we are taking that light there to represent the connection in the corridor, the dining area, as well as the kitchen, we now switch our MCB back on. As you can see, there is no issue. And then moment of truth, we switch that bulb on. My top boss, the bulb is on. All right. So that is the basic of troubleshooting, especially when it comes to circuits or lighting. So you go step by step. You ensure that you isolate that circuit. You ensure that you switch off that circuit, especially if the customer has said that there are sections in my house or in my business premises whereby I am not having lighting. Then it means that there is a problem with the MCB. What you need to do in that scenario is to simply go to the consumer unit and try and check where could the problem be. In most cases, you find that it is actually the MCB that has tripped. Now, there is also another scenario if there is a loose connection on the neutral. Now, this is where now things get very, very interesting, because you will now use your tester, right? So this is a tester. So using your tester, you will discover that at the output, okay, now that I have gloves, I may not be able to tell that. So the customer has told you that there are sections in that place that don't have James Kipruto is asking which intake is it, 2-phase or 3-phase? It is single phase. So if I place my finger right there, you can see that light turning on here at this glass, right? Presence of a phase. Assuming that that bulb is not working, but there is no neutral. Okay, I'm not going to do that because it is not good to disconnect a neutral. It is not good to disconnect a neutral in the presence of a phase. Otherwise, we would have showcased that, isn't it? So if you disconnect that neutral, when you use your tester, it will test on the face the presence of current. But that does not guarantee that the bulb will turn on simply because there is current that is flowing in the line. That is why you need a multimeter, isn't it? Because assuming that there is presence of current flowing through the line, and then the bulb is not turning on, you will have a lot of hard time troubleshooting, finding out where the problem could be. Even if it were the neutral that was faulty, it would be very difficult for you to know that indeed it is the neutral which is faulty without a digital multimeter to record the alternating current voltages, isn't it? All right. So that being said and done, my top boss, the same applies to, let's say, the sockets, right? Assuming that we have this socket not working, you simply go to the MCBs. If the MCBs, there's one that has tripped, you know there's a problem. And there's also another chance that the MCB might not have tripped, but there is no voltage output at the MCB. Could that be a scenario as well? Yes. Why? First of all, if the connection here, the cable has been connected on the insulation, we will not have an output to that socket, isn't it? Because again, an insulation is not a good conductor of electricity. Another thing is that if at all there is a loose connection on the neutral, the socket will definitely be affected. And last but not least, the cable itself or the connection in the socket. If it is not tightly done, the socket will not work. So you will have to open that socket and test for, actually you can do a physical check, isn't it? A physical check. So assuming using my socket here, sometimes you will find that someone was screwing this cable inside and then they screwed on the insulation. Assuming that when they were connecting the cable, they screwed on the insulation. Therefore, the flow of current is not sufficient inside the socket, right? So what if the earth wire has current? Good question. Great question. If that is the problem, there is a very high chance that there is a short circuit, either in the consumer unit, the conduit, or in that particular circuit. Maybe it is a socket. You find that there is that leakage that is happening. But again, that leakage goes back as a short circuit and trips the specific MCB, unless the wiring is poorly done, right? So if the wiring is correctly done, the MCB has to trip because that is also a short circuit. A short circuit does not only occur between the face or the line and the neutral only. A short circuit also occurs between the line or the face as well as the earth connection. Right. So something else that I would like to elaborate when it comes to troubleshooting is definitely on the wrong fixtures. Fixtures sometimes fail. Let's say it is this switch here. If it is not supplying power to this instant shower head, then the switch itself is faulty. So sometimes at the MCB level or at the circuit, the consumer unit level, you may find that everything is intact. All the MCBs are intact. They are up. Like you can see, very clean work here. The DP MCB, the RCCB, and all the MCBs have not tripped. Then it means that the specific circuit has a problem. If it is an instant shower head like this one, which is not working, it means that either the socket has an issue, and especially if the socket light is not turning on. For instance, these heating circuits, you will discover that they have with them those LEDs. If the LEDs are not turning on when the switch is turned on, then that is a first indicator that that specific switch or socket has a problem. It is faulty. So it has to turn on like the way it is turning on my practical board. If it doesn't, the switch itself is faulty, or the connection inside has a huge problem, right? So that being said and done, I am so grateful for your time, my top boss. We will have another video where we will do it practically in the field. I'll be showcasing you in a practical scenario whereby, apart from what we have done today on our board, we can see practical examples live on the field, and I'll be able to showcase to you how those issues or those problems are identified. Number one, thing as an electrical technician is to identify the problem. If you don't know how to identify the problem, it means that you cannot give solution to what you don't know. So you have to identify the problem before you can come up with a solution. The first way to approach an electrical issue is using a digital multimeter. So a digital multimeter will guide you easily to identify where the problem is. And we have said that a digital multimeter has a lot of features, as you can see, for voltages, for resistance, for capacitance, for continuity, voltages in AC, voltages in DC. Very, very helpful. So if you have it, it will definitely come a long way in saving you time and also helping you to troubleshoot it very easily. All right. So we will have that one-on-one session in the field, and I'll be able to guide you further, my top boss. I hope today's lesson has benefited you. If it has, give it a thumbs up on our video, give it a like, and if you have not subscribed to my top boss, subscribe. All of you who are watching currently, thank you so much for your time, and I will have more videos like these in the coming days. And my top boss, if you are watching this video as a recorded version, thank you so much for taking your time. All you need to do is to tell me where you are watching it from, be it Zambia, Ghana, Nigeria, Kenya. I have a lot of followers in Kenya, my beloved country, and I'm super, super proud to be a Kenyan. In Africa, I have a lot of followers. South Africa, South Sudan, Tanzania, Uganda. Did I mention Ghana? Nigeria? Super, super excited to have my top bosses watching me and also following me on other platforms. In UK, USA, in Asia, I also appreciate you so, so much. Thank you so much for subscribing to my channel, which is Top Heights Electricals and Electricians. England is in the building, courtesy of my top boss. Look, thank you so much, Vicky. So next time, my top boss, we will still talk about troubleshooting. We will also be moving to three-phase industrial wiring. I'll be taking you through contactors. I'll be taking you forward reverse motor connections. I will be taking you through three-phase distribution board wiring and explain to you how three-phase works, as well as give you an insight on how three-phase works with single-phase connections, as well as purely three-phase machines. And how is that entire balancing done? How is that wiring done, especially in an industrial setup? Thank you so much, my top boss, for tuning in. Thank you so much for keeping me company in this live stream. My name is John Gatehi, and I've been your host, and this is Top Heights Electricals and Electricians. Goodbye for now.